My name is Saitya from Triple Department. Subject microprocessor and microcontroller. Subject code AECD19. Assignment topic traffic light controller. Introduction to traffic light controller. Foundation of intelligent traffic management. Definition and purpose. A traffic light controller is an electronic system that manages the operation of traffic signals at intersection to regulate vehicles and pedestrian movement efficiency and safely. Historical text. The first manually operated traffic signal was introduced in 1868 in London, while the first electric traffic light appeared in 1912 in Salt Lake City. Modern controller now uses digital and adaptive technologies. Core functionalities: controller manages signal timing sequence, red, yellow, and green, based on preset algorithms. Real-time traffic flow or sensor feedback no optimize road usage. Importance in urban infrastructure. Traffic controller enhance safety, reduces congestion, and minimizes delay at intersection, contributing to improved fuel efficiency and reduced emissions. System integration. Modern systems integrating with IoT sensors, AI-based prediction models, and communication networks for dynamic signal adjustment in smart city ecosystem. History and evolution of traffic light system, from manual control to intelligence automation. Early beginning, the first traffic light was manually operated using gas lamps in London. Electrical signals emerged in earlier 20th century, introducing automatic switching mechanism. Electromechanical era. During 1920s and 1960s, traffic light using electromechanical timers and relays to manage simply signals cycles without electrical detection. Introducing of actuator system. In the 1960s was vehicle actuator signals based on loop detector, enabling dynamic light changing depending on real-time traffic flow. Digital and microprocessor controls. By the 1980s, digital control replaced analog system, allowing programmable timing plans and improved coordination among intersections. Smart and adaptive system. Today's system integrated AI, IoT sensor, machine learning to optimize flow dynamically, forming a key part of smart city infrastructure. Basic working principle of traffic light. Understanding the core operation cycle, signal phase and timing. Traffic light operated through defined phases: red for stop, yellow for caution, and green for go. Managed by timer or microcontroller that determine the duration of each phase. Sequential logic control. The controller ensures signals changes sequentially to prevent collision, maintaining consistent patterns across all directions using logic-based state transition. Fixed time and adaptive control. Fixed time system follows pre-programmed cycles, while adaptive control adjusts timing dynamically using sensors inputs or real-time data analysis. Coordinate and synchronization. Interconnected signals communicate to form green waves, synchronized light patterns that enhance flow analog major corridors. Safety and fail-safe mechanism. Backup power systems and fail-safe circuit ensures that in case of malfunction, the system defaults to flashing mode or safe operation state. Components of a traffic light system. Integration of hardware and software. Signal heads and lamps. Comparison red, yellow, and green LED clusters. Signal heads provides visual communication to drive and pedestrian. Modern design uses efficiency LEDs and weatherproof housing. Controlling the brain of the system, typically microcontroller or PLC, execute control logarithm, monitors inputs and manage output signals to light in real time. Sensors and detection. Inductive loop. Infrared sensors or video cameras detects vehicle presence and adjust signal timing. Communication interface enable networking between intersection and central traffic management sensor through wide or wireless communication. Software and control logic. Software supports adaptive algorithm using AI or rule-based logic. Logic design of traffic light controller. Infinite state mechanism SFM based approach. Finite state mechanic concept. A traffic light controller can be modeled as an FSM where each light configuration red, yellow, green presents a state and transition occur based on timing or sensors input. State representation. Each interaction phase such as north-south green or east-west green is represented as a sequence state. The SFM ensuring mutually exclusive and safe signal operation. Transition logic timing control. Timers define how long each state exists before transition, ensuring balanced flow and safely margin for vehicles and pedestrians. Errors, errors and safety handling. Fault state or emerging override can be included to handle malfunctions or emergency vehicles priority without disturbing safety. State diagram and timing sequence visualization, transition, and duration in traffic control. State diagram representation. The state diagram graphically depicts each signal state red, yellow, green, and the transition between them, forming a closed loop and defines the control logic. Timing sequence definition. Each phase duration typically 30 seconds for green and 5 seconds for yellow and the 30 seconds for green is controlled by timer or counters ensuring safety and steady flow. Phase transition control transition occurs sequentially based on clock cycles or sensors input. Advanced system dynamically after duration depending on vehicle density. Pedestrian integration. Pedestrian signal phases are integrated into main timing plan through parallel or intervalated substate synchronization to ensure safe crossing intervals. Visualization and debugging. Engineers uses timing charts and simulation links like MATLAB or multisim to verify correct sequence, avoid overloops, and ensure robustness. Hardware implementation of traffic light control. Combination logic rules def- defines instantaneous output red, yellow, green based on the current state and input conditions using Boolean expression and logic gates. Sequential logic integration incorporates memory elements such as flip-flop or counter to maintain the current state and enable transition over time, forming the FSM backbone. Circuit component. Core component includes AND or NOT, SJK or D flip-flop timer decoder. These are interconnected to produce timing-based control system. Clock and timing circuits. Clock generates or oscillators drives the sequential logic determining when transition occurs and ensuring system synchronization. Testing and simulation design are verified through table maps and simulation using tools like T-simologism to validate logic intensity and timing accuracy. Embedded system designed for signal automation, architecture overview, input and output configuration, programming logic, advanced of microcontroller uses, example implement, advanced of microcontroller uses, microcontroller enable compact, low cost and reprogrammable design with precise timing control and easy integration of new features, example implementation. A typically system uses an Arduino with three signals LED timer module and a AX sensor for vehicle detection demonstrating real-time adaptive control. High-speed hardware design using HDL. Overview of FPGA implementation. Build programmable gate array offers parallel processing capability ideal for real-time traffic control enabling fast and signal handling. HDL, the traffic control logic is describing using Verilog modules defining state timers and transition SFM are implemented using always blocks and case system. Advantages of FPGA system provides high speed performance, reconfigurable and hardware level timing precision with lower latency compared to microcontroller. Simulation and synthesis designs are tested in simulation tools like Model Sim before being synthesized into FPGA. Smart traffic light system IoT and for adaptive control, IoT-based connectivity, LiDAR to collect real-time traffic flow, AI-driven decision-making, vehicles to infrastructure, V2I communication cloud, and edge mounting, sustainability and efficiency. Real-time case study, urban traffic management, global example of intelligence signal control. Singapore traffic, smart traffic ecosystem, Los Angeles, automated traffic surveillance and controls, London school system, Pune, India smart city innovation impact assessment. Challenges and limitation of traffic light system, hardware failures and maintenance, limited adaptability in fixed time system, integration complexity, environmental and energy concern, data privacy and cyber security. Future trends and innovation in traffic control, shaping the next generation of urban mobility, AI-powered predictive control integration with autonomous vehicle, quantum and edge computing application, sustainability, urban mobility, digital twins and simulation platform. Conclusion and summary, keys insight from traffic light control design, comprehensive understanding, evaluation of control system, role of FSM and logic design, integration of modern technologies, future outlook. Thank you.